the potential of IoT in terms of building systems, building devices, deploying them, analyzing them, and trying to solve some of the real life problems. So this is where my group, the SWAN research group in IIT Kharagpur, which I think many of you have heard about, which is well known globally as well, is very much active in terms of research in this particular domain. So this connectivity, let us dive a little deeper into it. So we have seen that we need connectivity between different devices, these IoT devices. Now, what are these IoT devices? I told you already that these IoT devices have sensors. One of the components is sensors. But then there are different other components as well. There is a module which can help in communicating between the different devices. So you need a module which can send the data across after it is sensed. You need a device, a component which can do some brief processing, right? So there are processors there, microprocessors or microcontrollers more specifically, which are there. And you also need, like computers, like mobile phones, you also need something to power up. So batteries basically, right? So these are some of the different components that are possible to be put in the IoT devices. And then you have the connectivity, and once you have that, you gradually build up the network, you scale up depending on the application requirements, the domain requirements, and what you get is a system which can help you solve different problems. Now this is one part of the story, but what is the other part? You get a lot of data, right? How do you handle that data? So that data basically will have to be stored, that data will have to be analyzed, will have to be processed, and so on. So for which basically we already know that there are so many traditional, database management techniques that are there. There are techniques through which we can analyze data. But the challenge is that these IoT devices, they have certain peculiar characteristics. They are very, although they have all these different components like processors, etc., but these are very, very much resource starved. They're very much resource starved. So if you have to, for example, if we have to execute some security mechanism, like, implementation of PKI, for instance, or RSA algorithms implementation, those are very much, they consume a lot of resources. You cannot do that on these IoT devices. So that is where a lot of research challenges exist, and this is what people have been trying to work on. So IoT is an area which has grown leaps and bounds in the last few decades in terms of research. So much of funding has been poured by government in the country and beyond, and also the industries globally, to basically address many different aspects of these different challenges, right? So now what we do? So why, the fundamental question that can come in your minds is, why do we really need to connect these physical objects like the ones that I just mentioned? So that's basically to fulfill certain use cases in an attractive manner. So you must have heard about smart cities, smart homes, smart hospitals, right? So that smartness basically comes due to the adoption of IoT technologies, right? And so if you think about the IoT architecture, there is no standardized architecture of IoT, by the way, right? In the same way as for the internet, there is a standardized architecture, the 5-layer, 7-layer architecture, and so on. But for IoT, there is nothing standardized. So intentionally, it has not been standardized. But, so generally, if you look at across all the different propositions of how you are going to visualize this architecture, typically there are 3 layers. The bottommost layer is called the perception layer, which basically constitutes different types of sensors and so on. Then there is a processing layer, which can do some, processing close to the source of the data, like close to the IoT devices. And these data are sent across, and Then there is something called cloud, where which is like a massive kind of server. If you do not already know about cloud, you can think about this way. But it's much beyond that. So typical implementations, including the implementations that we do in our lab at IIT Kharagpur, basically looks into all these three different layers. So these are some of these different components, right? I was talking about the sensors, as you can see over here. These different sensors are there, right? So I'm not mentioning which sensor does what, but as you can see, like these are some of these pictures. Then there is something called actuator. So sensor has sensed something, then the data has been processed. Then do what? You have to do something. For example, in an agricultural field, right? It has been sensed that the soil moisture has gone down. But then how do you bring that soil moisture up? For that, you need to turn on the water pumps, right? So for this, you need actuators which can automatically do it. So there are different types of actuators. Similarly, development boards are there, right? So different types of development boards which have different types of processing capabilities and so on and so forth. So these are some of these different pictures of these different components of IoT devices. So I was telling you that you have sensors, you have applications running on top, but in between, we also need we need to facilitate the interconnection of the different sensors, so network layer. And then, IoT as a whole is more service centric, right? We are doing so many things because we want to do something interesting for the society, for serving different types of use cases, for the industrial use cases, for societal use cases, and so on. So that is where there is a specific layer which is called the service layer. The service layer basically talks about how you can compose different services, how you can decompose different services. So that's again, it's a complex kind of territory with different complex algorithms running behind the scenes. So this is what I was talking about. So why we need to do whatever I told so far? Because we want to fulfill certain attractive use cases. So these use cases can come from different domains. These domains could be agriculture. So as you can see, this is a picture of a drone which is spraying pesticides in an agricultural field. And not only one drone, but as you can see in this picture, it's a network of drones. It's a swarm of drones which together are collectively performing certain tasks, right? So then in the industry also, right? Industry floors, different machineries in the factory floors, they can be connected to fulfill certain tasks. Like as we know, like in manufacturing sector, for example, there are conveyors, right, which are used. So you have different machineries that that do certain things, and after fulfilling the task, they put the job into the conveyor. It goes to the next platform, does certain things, and so on. Things move. So you need connectivity over there as well. This is one of the examples of applications of IoT in the industry, but there are tons of other examples as well. Transportation, the roads on the vehicles on the roads, they can also be connected for good reasons. You want to know if there is an accident in front of you. You want to know what is the condition of the road. There are multiple different road possibilities, like in Google Maps, etc. We know, right? So which of these roads have lesser number of potholes, for this case, right? Fewer number of potholes. So like this, there are so many things that you can know through this connectivity mechanism, right? So you want to get connected with the vehicles which are on the road, right? So all these are possible. So this is where smart transportation basically comes into picture. So these are some of these examples. So our group is very much active in research in in the domain of aerial IoT, and we use a lot of unmanned aerial vehicles for that purpose, drones, right? We are more interested in connectivity between the different drones, right? So a swarm of drones which can accomplish a particular mission, right? This is what at a broader level, at a higher level, our research group targets to work on. And there are different types of formations, how you can have these formations. These networks are basically self-organizing. So self-organizing networks basically have their own peculiar characteristics, which I am not getting into the details, but these will have to be worked on, and it's not easy, right? So uh, research groups across the world work on all of these different aspects, and but still there are a lot of challenges that remain. So similarly in agriculture, this is also another picture from our agricultural field where we have used drones and network of drones basically to fulfill different other purposes. This is basically a picture from the agricultural farm in IIT Kharagpur, and the picture is a bit dated, but nonetheless, you can understand the purpose of how purpose of this picture, like how these drones can be used in order to fulfill certain missions, right? So we built this system since it was long back, right? This is a mature technology. We also, our group is not very much active in terms of building sensors because that's a specialized area. We are more into connectivity, but so sometime some of my students took interest in building sensors as well. So this is a water level sensor, conductivity based water level sensor, which was built, successfully tested in the different agricultural farms in and around IIT Kharagpur. And this is also like another application I can show you of use of different IoT systems in the power sector. This is a work that we did for CESC Kolkata, where we used IoT for addressing certain problems of electrical substations, right? And yeah, so that's the power sector. Similarly, IoT applications, many applications are there in the healthcare sector. I'll just narrate one of the works that we did long back. 2013 we did it, which was called the AmbuSense. That's basically inspired from one of the tragic incidents that happened with one of the students of IIT Kharagpur, who was taken in an ambulance from our healthcare center to a Kolkata hospital, and in between basically the student died, and that basically inspired me to work on a system, to come up with this system which can help in monitoring the condition of the patients end to end, right? So the referring hospital doctors and the nurses and the referred hospital doctors and the nurses continuously, they can monitor the condition of the patients and take necessary actions accordingly. So this is a space where a lot of opportunities exist, not only in terms of implementation but also in terms of research, because there are in number of research problems that will have to be addressed in order to have this use case fulfill its purpose. So we this is for students particularly. I just wanted to show you how technologies can be evolved, matured, and basically shipped out, right? So AmbuSense evolved due to the market demand, and we came up with, we have a startup which basically looked into the task of how AmbuSense can be commercialized. So the commercial name of AmbuSense is AP1. AP1 again has gone through different evolutionary stages, and AP1, V1, V2, and so on. So these are not shown over here. And AP1, I mean, so those of you who want to know more about AP1 and the different other products that we have built in our labs in IIT Kharagpur and we are trying to commercialize, these are basically there on our website. My startup's name is Sensor Drops Networks, and if you are interested to know more about these offerings, basically you have to visit www.sensordropsnetworks.com. If you type, you will be able to see yourself about the different products that we have on trying to address different application requirements. Now, let us talk a little bit about the intelligence part, right? So you see that getting a lot of data is one thing, but for autonomy, we need autonomous systems, right? Autonomous systems basically ideally do not want human intervention. So we want to minimize human interventions, right? So for which there is no one technology, there are so many different technologies which will have to be put together in order to fulfill this dream. Now, along with this kind of development that has been happening in the connectivity space, a lot of research is going on, as we all know, on AI, ML, deep ML, and so on, right? So can we adopt some of these solutions over here? Yes, we can. People are trying to do, but we are still not there yet. A lot of research still remains, because the challenge is that most of these machine learning things that you can think about, implementation of convolutional neural networks, implementation of anything else that you can think about, which you would be otherwise running on a cloud, you cannot do the same on the device itself, because as I said earlier, these devices are very much resource starved, and one such important resource that is required for the purpose is the computing capability, computing power. So this is where resource constrained machine learning comes into picture. And resource constrained machine learning, because of these constraints, is highly challenging. So I have two PhD thesis students who have graduated. Their thesis was on constrained machine learning, but there is whole lot of work that still remains in this particular domain. So this is particularly important for potential researchers over here who would like to explore this domain of machine learning. You want to work on machine learning. Now, many times I get queries from different research scholars that what are the different problems that are existing. So if you are curious to know more about machine learning and you want to contribute over here, this is one such place where you can do something. Along with that, we all know about ChatGPT, all these generative AI stuff, explainable AI, reliable AI, generative AI. So all of these are evolving. So can we adopt some of these ideas that we have been doing for the internet and internet connected devices, and can we bring them down to IoT devices, right? For the same reasons that I narrated earlier, the challenges are many, and still people are doing a lot of work in this front. So one such example is we have been trying to build a smart campus. A smart campus where, again, anything, everything, or everything connected, right? So in my current role as the Associate Dean of Infrastructure, so this is something that I have been trying to do in the last few months, connecting everything. And also due to my interest in the generative AI space, I have been trying to explore with some of my research scholars about how we can fulfill things like AI-enabled query management for smart campuses, right? So, for example, querying the different campus services, requesting campus navigation, receiving notifications, right? Health-related issues, automatically identifying potential health hazards. We know about the mental health issues that are going on around in different campuses. So, automatically by taking cues from different data, for example, on-campus camera installations that are there, those are there for a certain different purpose, but can these also contribute to indirectly identifying potential mental health related hazards among the students in the campus, right? So this is all different works that are going on. I just wanted to sensitize you on this front, and the main purpose is to also impress upon you the complexity that lies underneath. We have so many different aspects that will have to be addressed individually and together. The convergence is important, it is required, but it is extremely challenging. This convergence of all these different bubbles that you can see over here is something that is required, has to be done, but challenging. And the good thing is that for potential PhD students or potential researchers who want to do something, these are some inputs for you where you can find some good research problems to work on. I would, yeah, so can I take another 5 to 10 minutes? 5 minutes, okay. So there are so many things to talk about, but I think gradually I will conclude. So we are in the education sector, right? So we also want to know that what all things are possible in terms of improving the education, the academic infrastructure, right? So what all things are possible, and this is not something that is it's a scientific fiction. These are not scientific fiction. These are possibilities. We already know about Google Glass, right? Most of us, we have heard about the smart glasses, where the AI tutor basically can adjust the lessons in real time. I'm speaking and I see that people are getting bored. So automatically I can adjust my lessons. So that feedback will automatically come because of the smart glasses that I would be wearing as a tutor. Virtual reality based learning, where the students would be experiencing the historical events in simulations. Wristbands, IoT based wristbands, smart watches, these are already there, right? Many of you already possess these devices, right? Then holographic teachers. This is also something that is happening. I mean, these are not like sci-fi, these are happening. So some research labs in Europe, they have built holographic teachers, right? So you will have some kind of virtual teacher standing in front of you, right? You press some button, automatically the tutor will pop up and will address some of your queries and again go down like a ghost, right? That kind of thing. So these are all happening, as you can see, like all research works in this domain, right? So you can see that animation over here. So AI powered smart classrooms, IoT for assessment. So one thing that is very much interesting and is the future is teachers are very much curious to get feedback on the assessments that are given by the teachers, right? I want to know, I want to change dynamically. I want to change my questions based on different factors like how much the students are able to understand and so on and so forth. So dynamically changing the pace and the content of teaching as well as the assessments, all these things can be fulfilled through some of these concepts that I have been mentioning in the last hour. So that's one thing. Now let us look at, some of you might be having some interests in terms of the business. So what about the business part, right? If you look at some of the business trends, the analytics that are put by different these groups, like many of these research group business, what are these called? These market research groups, right? Like Boston Analytics and so on. So they have basically projected the growth of IoT in this manner, the business growth of IoT in this manner. As you can see, that's pretty steep. The curve is pretty steep, right? So there is a lot of business opportunity that also lies, right? And in terms of the industry, right? How IoT can benefit, we know about the adoption of IoT in different industries like Tesla, right? Where AI-driven predictive maintenance is being used in car production. Amazon is using IoT for powering the warehouses using robotic automation, real-time inventory tracking and automated quality control, workplace safety with the help of IoT. This is something that one of my researchers, co-researchers basically, has been working on. with Tata Steel. So there, the whole idea is that there are a lot of ergonomic issues, right? So, for instance, the crane operator does a particular job in a particular fashion by sitting in a particular position for several hours at a stretch, because of which lot of health hazards basically are there, and the workers basically they suffer, right? So how basically these IoTization can help in improving the workplace safety is something that is of interest to some of the prominent industries like the Tatas and so on. Road transportation, also I told you earlier that road conditions, whether there are sharp turnings ahead, whether there are potholes ahead, whether there are accidents on the road. So all of these can help us to dynamically decide the next course of action depending on the situations that are prevailing on the road. So this is basically, these are some of these pictures that are taken from some of my research papers where we have shown that to address this kind of problem, you need to do in an abstract, in an abstracted manner. So different layers, basically device layer, edge layer, decision layer, and decision virtualization layer. So decision virtualization is a concept that about 10 years back my research group basically proposed. Decision virtualization. You must have heard about different types of computer resources virtualization, but we argued that for addressing some of the practical problems, we also need to virtualize the decisions, and that's something that's quite philosophical, and but it's very interesting. We got a number of research papers published in prominent venues because of this particular work. In terms of societal contributions like tribal welfare, we already executed some projects. We are still executing some projects. So earlier we did some work in Chhattisgarh tribal villages. So our intent was to contribute to the goal of building smart tribal villages, addressing different problems in terms of agriculture, healthcare. So tribal agriculture is very typical, right? Similarly, some of the healthcare problems among the tribal people are also typical. So we have built affordable devices which can help in screening and early diagnosing some of the health hazards that are there in these communities. In retail e-commerce, also same thing. We have already seen in bits and pieces, right? Like for example, if we go to some of these big departmental stores, we have seen that these are RFID tagged, right? So RFID tag is also a component of IoT, right? So this is already happening, but then interesting things can come up once you basically all these tags also if you network them, right? But then it is interesting but challenging. So what are the different challenges that are there is something that people are working on. This is my startup, right? Sensor Drops Networks, and this is what I was talking about. So any of you who is interested to know more, you can look into it. Okay. So I think so this is a good place to end, and I would like to take up any questions that may be there.
Professor Misra has explained so many things about IoT, how this IoT is bringing magic to our life in every sphere of our life. And he explained about the connectivity of the IoT devices. I think that the latest example he missed, we have all seen that in the last assembly elections, all that web cameras are used in every booth to make the connectivity so that election process can be monitored. Okay, so I think this is the latest example of IoT, that connectivity. And so without wasting time, I will first go to the online participants if there is any questions.